All right, this video is going to be a review of the first three sections of Chapter 7 and getting ready for a quiz on those sections. And I thought this was pretty funny meme. I don't know where this baby picture came from. That's pretty hilarious. So yes, quiz today. All right, so the first couple sections were about calculating interest, and there's two ways to do it: continuous and annual. For all of these questions, pause the video, try them, see what you remember. That'll be the best for learning, right? There's a pile of research that says trying to remember how to do something is far more valuable than just watching me do it. So try it first and then unpause the video to see my solution. All right, so you have 40,000. That's a pretty good deal. And it's compounded continuously. So that's the key word that tells us we're going to use this formula, the continuous formula, the PERT. So P is just the initial amount. Okay, and then we're going to do E, and then the rate as a decimal. So 5%, I've got to move it over twice, right? So the rate as a decimal, once I move it over twice, is 0.05 times 3 years. Okay, and if it was the yearly formula, it would look somewhat the same, 40,000, and then do 1 plus the rate again, so 5%. Okay, and raised to the power of 3, because we want to know after 3 years. Okay, so we can do these on the calculator and kind of compare and see which one is better. Hopefully you remember which one is better. But all right, so 40,000, and then the e to the x key is right here. And then in parentheses, I'm going to do 0.05 times 3 years. Close the parenthesis. I think it was 3 years, right? Yeah, 3 years. Okay, and then the other one, 40,000, 1.05, 1 plus 5%, and then raise that to the third power. Okay, and you can see they're pretty similar, but it's actually at least $100 more, maybe $170 some dollars better to do the continuous version. All right, so looks like the continuous is a little bit better off. And again, the first thing you should do on every question is which formula to use. All right, so you're gonna buy a Maserati, depreciates 15% per year. How much will it be worth in 3 years? It's a pretty nice looking Maserati. Pause the video, give it a shot. Okay, so we're going to use the non-continuous because it doesn't say anything about compounding continuously, which is actually good for us in this situation because we don't want compounding the interest to compound quickly here because it's losing value. All right, so I'm going to do 100,000, and then I'm going to do the rate as a decimal, so 15%. Move it over twice, and you'll get 0.15. So I have to do 1 minus 0.15 because I'm losing value, and then 3 years. Okay, so what this formula actually is saying here in a second is we're going to have 85% left each year. So we're going to multiply by 0.85 3 times, and that'll make our Maserati lose value. So I'm going to do it quick on the calculator and transfer my answer. All right, so in 3 years it lost a ton of value, almost $40,000, and we're at $61,412.50. And that was the first two sections, just about those interest formulas. All right, and then the last, oh, I actually have one more. This is a pretty good exponential interest one that I thought was pretty tough. I saw this on a sample like MCA question, and I think a good thing I'll give you is to do a table, I guess, to try and help figure this out. I think that's a good way to do this. So pause the video and make as much sense of this as you can. Okay, and so in this case, we've got hours, and then we've got the population of bacteria. And I think at it doubles every 3.5 hours. So I want to say like at the start, our population, as initial of P, all right, it says that right there. Okay, and then 3.5 hours later, if it doubles, we have twice P, right? And that starts to look at our answer choices, right? But that's after 3.5 hours, so that's not good. We want to do 20 hours. So then after, let's see, 7 hours, after 3.5 more hours, it doubles again. And we can kind of keep going with this pattern, 3.5 more hours and double this. 3.5 more hours, 16p, and then 3.5 more hours, and we're at 32p. Okay, and then what happens is we land actually on 21 hours, and that's 64p. So we know that like 20 hours is like right in between these. And so my guess is it's going to be 50, right? 64p doesn't happen until 21 hours. So 20 hours we could reasonably guess would be at 50 times the initial population. Right? Kind of an interesting, goofy question, but I think a table really helps to answer that one. All right, so then the other part is log. And so I just wanted to pause the video and see if you remember what is a log. Okay, and remember log means find the exponent for the given base. So when you do evaluate it, you put the exponent here. So this one is really saying a base of 7. What is the exponent that gives me 49? The answer to that is 2. All right, and then if nothing is written here, that's an invisible 10. So the second one is going to say 10 to what power gives us 100, right? Find me the exponent for base 10, and that answer is 2. Okay, so if they're harder ones, then it's good to start using a calculator. So like this one says like 36, what is the power, right? What is the exponent that'll give us 6? And that's a harder question. Some of you might be able to do that, but that's definitely a harder than any of the ones on the previous slide. So the way the calculator can help here is there's two ways to do this. There's a special log base button on the calculator, or you can do a change of base, which does log base 10 over log base 10, right? So see if you remember which number goes up and which number goes down. Okay, and hopefully you can remember that this number, whatever here is, goes up, and whatever number is lower down there goes down, right? So you can type that in your calculator and you should get 1/2. Okay, so I'll demo that for you one time here quick. There's two ways to do that. You can do the log of 6 divided by log of 36, and that you do your log base 36 of 6. That's one way to do it, or you can do the log base button. So do math and go up to log base, and we had a base of 36 and a value of 6, and hit enter, and you get the same 1/2. All right, so I don't think we need to do the other one, but just as one more time, you can think about what number goes up and what goes down if you're doing the change of base. Hopefully you know 154 over 6. And I'm not even going to bother with the rest of that. You could do it on the calculator. Hopefully the first example is good enough there. All right, a few to practice switching forms. I think that's the huge objective that we needed from that. It was actually objective 2 from yesterday, but at any rate, see if you can switch forms on these. Okay, so these little equations will definitely help. I always start with the base and the exponent. So I'm going to write log, and then this is my base. There's my exponent. So I'm going to do log base 1/3. Log means find me the exponent, so the exponent goes there, and then the value goes there. So log base 1/3 of 9 equals -2. All right, next one, I'm going to do log, and then we have a base and an exponent. So base is 1/4, exponent is 3, and then the value is 1/64. All right, switching the other way. So I always start base exponent again. So in log form, base is a little number there. Since log means find exponent, the exponent is on the other side. So I'm going to do base exponent equals my value of 32. All right, last set here. Sorry, the last one got cut off, but we won't worry about that. So this is for some Chute Block. So if you've never seen The Office, this is a Chute Block. It's not quite as good as Stanley Nickel, but it's all I got. So try these 3. These are kind of challenge ones, and I encourage you to try it without the calculator. Certainly you could type them in and figure it out that way, but see if you can figure it out without the calculator. Pause the video. All right, so the first one is base of 2. What is the exponent that'll give us -32, right? And there's nothing that you can do here, right? So students might think it's a negative exponent, but remember what negative exponent means is do the reciprocal. So like if you wanted to do 2 to the negative third, it'd be like 1 over 2 to the third, right? And that's not going to give you a negative number, right? So this one has no solution. All right, second one, I think is actually going to be a negative exponent example, because if we switch forms on that one, I'm looking for 64. What is the power that'll give me 8? And nope, I was wrong actually. So that one you have to remember that like a half exponent is the same thing as a square root. So 64 to the 1/2 power, right? This is a power of 1 and a root of 2, if you remember from chapter 6. So this is the same as a square root. So that'll give us 8. So the exponent we need here is 1/2. Okay. And then the last one's kind of a goofy one, but this is saying like 7, what is the exponent that'll give us 7 to the third, right? Because our value is 7 to the third. And so if you can kind of just do this mentally to make these two sides equal, you're going to need 3, right? Because then you'd have 7 to the third equals 7 to the third. Kind of a goofy one. When these parts match, I think your answer is just going to be the exponent. But all right, that's it. If you got any of these right, ask your parents for a Chute Block. All right, that's it. Good luck with the quiz, and thank you for watching.